Good morning, ladies and gentlemen. May I have your attention, please? Thank you. We're going to have an opportunity to do some time test practice and get some familiarity with what kinds of questions could be asked on the multiple choice part A, non-calculator, and multiple choice part B, calculator allowed. But first, let's go ahead and take a look at our Bellwork for today. So raise your hand if you did not get a red mark. Great. So if we're given a picture of a graph, right? If we're given a picture of a graph, we can visually estimate the average value of a function by thinking about those function values that are attained over the course of the interval and trying to, visually estimate an average function value over the course of the interval. In this particular case, we see my curves sinusoid, right? We see our curve sinusoid, and it looks like we spend, right, some time getting up higher, some time lower, and so if we wanted to visually estimate the average value attained by this function over the interval 1 to 7, we could consider my interval 1 to 7 and visually estimate an average value, I don't know, somewhere maybe in here. Again, that's just a visual estimate, right? That's a visual estimate, and it might not be very good, but we'll see. Let me get a little more. We'll see. We'll see. All right. So now we're going to go ahead and numerically. Remember, numerically means calculator allowed. We can use the built-in capabilities of the software on our graphers. So numerically calculate the average value of f on the interval 1 to 7. We're going to show the setup. That's the calculus setup. And then we're going to answer correct to 3 places past the decimal in accordance with the College Board AT curriculum. So here we go. We know that average value in general is given by the integral over my interval of my function itself and then divided by the length of my interval. So my calculus setup for a defined f of x, right, who's given, would be the integral from 1 to 7 of f of x, and you could write that out as 4 sine of quantity x over 2 closed angle plus 3, or if it's been defined for you, you can write f of x on calculator allowed over 7 minus 1. And think of this in terms of the calculus here. The integral is like an elongated S where we're summing up, right, each of those function values, f, attained over the course of the interval, just like you add up the test scores when you're going to find your average test score. So we're summing up all the function values. Then we're going to go ahead and divide by the length of the interval in which those function values could be culled from, and then we'll get our result. So this is numerically, we're all about the math 9, comma baby. So we'll math 9 from 1 to 7. My function, I better check my mode here quickly. I want to make sure we're in radian mode, okay? So we're going to make sure we're in radian mode for sine of angle x over 2. Close angle plus 3. Close expression dx. And let the math work its magic. Divided by the length of my subinterval was 7 minus 1 is 6. Looks like I'm getting 5.419 is my correct to 3 places. So let's go ahead and write that correct to 3 places. So that's about 5.419 correct to 3 places. Raise your hand if you already got that numerically. So we've already got that. Way to go. How did I do with my visual estimate? Not so good. 1, 2, 3, 4, 5. So it looks like I was just underneath it, right? Just underneath it. Now that we know what my average value is, right? My y average, I can go ahead and draw a rectangle whose height is that average value. So now I'll go ahead and do this a little bit better. We know from 1 until 7, our average value is 5.4. About. And purple for Warrior Pride. Yes, purple. Good. And 1 until 7, 1, 2, 3, 4, 5.4, and 1, 2, 3, 4, 5, 6, 7, and so it looks like now the area of that rectangle, right? The area of that rectangle whose base is my width of the interval b minus a, and whose height is that y average f of c value, right, is exactly equal to the integral of my function f, right, over the interval 1 to 7. That, of course, is the exact area in between my function f and the x-axis on the interval 1 to 7. So we've got a lot of visual connections here. So here we've got our integral of my function from 1 to 7 would be this irregular shaped region. Right? We've got that irregular shaped region. And we've got my area of the rectangle. And the area of the rectangle is going to be exactly equal to the irregular shaped blue outline region. That is the exact area between the curve and the x-axis over the interval. So let's see, how can we write that exactly the same? We'll go ahead and say that my f of c, my y average, multiplied by the width of my rectangle, b minus a, is equal to the exact area in between my function f and the x-axis on the interval 1 to 7. And so there we have our visual representation. There we have our formulaic. Here's my height of the rectangle. Here's my width of the rectangle, or base of the rectangle. And then here's my area between curves. Awesome. So who had exactly the same? Exactly the same areas. That's the point, right, of our mean value theorem for integrals. It reminds me, harkens back to the day when we had the mean value theorem for derivatives, right, where we found that perfect height of a rectangle, such that when multiplied by the width of my interval gives me the exact value of the definite integral. Right? That's what this is. Again, now just in the context of integrals. Okay, so we'll go ahead and say exactly the same. Awesome. What questions do you guys have about today's Bellwork? Okay. Then let's go ahead and pause the recording here, and we'll take out your OTL number 2 and give yourself credit for those you can. Okay, ladies and gentlemen. So our AP Calculus exam, section 1, right, and section 2 are equally weighted. So half of your AP exam score is based on your performance on section 1, the multiple choice portion. Half is based on section 2, the free response portion. In the multiple choice section, there's 2 parts, part A and part B. Part A is non-calculated. It consists of 28 questions, and you're given 55 minutes time. Part B is calculator allowed. The reason it's called calculator allowed isn't because you need a calculator in every single question. In fact, there's only select exercises where you're required to use the functions in your calculator, right? There are many questions on there that you don't need a calculator for at all. In any case, it's calculator allowed, so you have access to your calculator, but calculator is not necessary on many of the questions. However, there are several exercises, and on this practice exam, they're indicated with an asterisk, a star, where you have to use one of the built-in functionalities of your calculator, like Math 8 was our n derivative and find a numerical derivative of a function at a particular x value. Math 9, where we could calculate numerically the definite integral like you did in today's Bellwork for part of your average value calculation. So there's some things where you have to use your graphing calculator, or second calculate intersect in order to determine the solution, right, of an equation that we can't do algebraically. And so stuff like that is on the part B. Got it. Awesome. So our part A, 28 questions, 55 minutes, works out to a little bit less than 2 minutes per question. Part B, 17 questions in 50 minutes, works out to a little bit less than 3 minutes per question. So it's kind of moving and shaking. As we practice over the next couple of weeks, you're going to get a kind of a feel for your timing. And you want to make sure that you're not spending too much time on any one exercise because they're all weighted the same. They're all worth the same amount. And so you don't want to get caught up trying to figure out, right, number 13, because you know this, but you're spending 3, 5, 6 minutes on a single question. That's not going to be a good use of time because you'll run out towards the end. So you want to make sure that you're developing those good testing skills. All right, today's practice test is multiple choice part A. Non-calculator, it's the blue one, 14 questions, everybody find it. It's the blue one, not test W. I'm putting that on pause. It's the one that says calculus AB part A in double underline. You may not use a calculator on this portion of the exam. There's 14 questions, so today we're going to use a writing utensil and go for about 27 minutes, right? Then we're going to switch gears over to the part B. If you finish before then, right? If you finish before then, you can go ahead and switch your writing utensil colors and take a look at the answer key and go through and score and start making corrections. Making corrections on your practice is going to be part of your OTL tonight. So if you finish before the 27 minutes, then you can go ahead and switch over to a different color writing utensil and make corrections using the answer key, which is on OTL number 3. Then, after the 27 minutes have passed, we're going to go ahead and switch over to part B. This is calculator aloud. The calculator aloud portion, right, is for practice only 10 questions. That's about 29 minutes, and so we're not going to have time to finish that. But we'll get you as much of that as we can during class time. Again, you'll be responsible for finishing that outside and making corrections as part of your OTL. The answer key is provided on OTL number 3. Whew. I wanted to make sure we could have our test conversation, and so we're not going to quite make it today in terms of finishing this up in class, but that's okay. We'll get close. And so let's go ahead and go to part A. This is just for practice and familiarity, but I would ask that you go ahead and try it by yourself during this time. If you finish before the 27 minutes are up, then go ahead and switch to a different utensil and start correcting. Does that make sense? Let's go ahead and begin on the blue practice exam. Thank you. So 55.